Hi everyone, my name is Hamted. Welcome to today's tutorial. We're answering question 2 from tutorial sheet 4. So if you've not yet subscribed to my channel, kindly do so that you don't miss out the videos that I'm going to be posting on the channel. Alright, so we proceed. So the question says sketch the graphs of the following equations, and then these equations are y is equal to x squared plus 3x plus 2. We also have this one, we also have that one. So I'll sketch 2 from these equations, and then you can also sketch, and then if you sketch you send the solutions. I'll confirm whether you're correct or wrong. Yeah, so if you need my outline you can check in the description, or let me just write it here. This is my outline. So you can use WhatsApp to contact me, or if you need help in any kind of mathematics you can just call this line. Okay, so the question says sketch the graphs of the following equations. Okay, let me check. Alright, sketch the graphs of the following equations. So when you're sketching the graph, you need first to identify whether it has a minimum or the maximum value. How do you check that? If it's a quadratic equation, just check the coefficient of x squared. If so this coefficient of x squared is called a, from the expression a x squared plus b x plus c is equal to 0. So this one is called, so in this case we're using y, so put y there. We have a function. Okay, so this first the coefficient of a is called a. So if it's greater than 0, then you conclude to say it has a minimum value, and then if a is less than 0, conclude to say it has a maximum value. So in this case, when you look at the coefficient of x squared there, it's greater than 0. It's 1, which is greater than 0. So meaning it's going to be a minimum value. It's going to have this. So our graph is expected to come out like that. So let's quickly start sketching. So how do you sketch? The first thing that you need to do when sketching is to find the x-intercept. So to find the x-intercept, we know to say in the x-axis, the value of y is equal to 0. So here we're just sketching, we're not drawing. If you've been told to draw, you make sure that you draw a table of values and draw it nicely. But here we're sketching, so we just need important points to sketch. So in the x-axis we know to say the value of y is equal to 0. So meaning while there is y here, we're going to put 0 and then find the values of x. So we're going to, let's try using factorization method. The product will be 2, the sum will be 3. So we can use 1 and 2. So we can say x squared plus x plus 2x will give us 3x. Then when we multiply them, we'll get 2 is equal to 0. And then we factorize. So we're going to have x plus 1 there, then 2 there is common, we'll have x plus 1 again, then this is equal to 0. So x plus 1, and then we have x plus 2, which is also equal to 0. Then we equate these to 0. So when we equate these two to 0, we have our value of x to be equal to -1. Then the other value of x will just be equal to -2. So these are the points at which the curve is cutting the x-axis. These are the ones that we're calling the x-intercepts. And then let's also find the y-intercept. So to find the y-intercept, we know to say in the y-axis, the value of x is equal to 0. So we just put 0. So we just put 0 where there's x in this expression, and then if you put 0 there, you also put 0 there, we're going to have these to be 0, meaning we just remain with 2 there. So meaning when we put 0, so we say y is equal to, where there's x we put 0, so we have 0 squared plus 3, then we put 0 there, plus 2. 3 times 0 is 0, plus 0 is 0, plus 2, we get 2. So our value of y is equal to 2. So this 2 is just a point where it's cutting the y-axis. So after finding the x and the y-intercept, we can now find the turning point. So to find the turning point, we have two methods. We have completing the square method and just the normal method, where you say at the turning point. So you can say at the turning point, the value of x is equal to negative b over 2a. At the turning point, the value of x is just negative b over 2a. So you say x is equal to, what is our b there? To be negative 3 over 2. Our a is 1. So when we put 1 there, we still get 2 times 1 to still give us 2. So this is, so negative 2 over 3 is the value of x at our turning point. Now we find the value of y at the turning point. The value of y at the turning point, you just replace this negative 3 over 2 in this expression. So I'm using the first method to find the turning point. We're going to use completing the square method to find the turning point in this on the second question. So here let's use this method. So y is equal to negative 3 over 2. Sorry, this is 2. So we have negative 3 over 2, and then we square this, then plus 3 negative 3 over 2, then plus 2. So when you simplify this, we're going to have something like so when you simplify this, you get negative 1 over 4 as your solution. So once you simplify this, you now conclude to say my turning point of the curve that I'm going to sketch will just be negative 3 over 2 comma negative 1 over negative 1 over 4. So from here now you can even go straight into sketching. So you can sketch. So let me just write it this way. Okay, it's okay like this. Okay, so we have that we put first the turning point. So the turning point can be I'll put it to be there. I have my negative 1 over 4. So we're just sketching. We just look at the important point. Then I have my what's this, the turning point. We first put the turning point, so I can write my negative in the x-axis, my negative 3 over 2 somewhere there, negative 3 over 2, and then in the y it's negative 1 over 4, so which is just that point. So this is my turning point. Then it's cutting the x-axis at negative 1 and negative 2. So I'm going to say this is my negative 1, and then this is my negative 2. So I'm going to sketch my curve like that. It's going to pass through my turning point, go up like that, then to end there. So here at this point where it's cutting the y-axis, that's where my y-intercept is, which is the 2. And then from there, so this is the turning point. and then I think we are done with sketching. So you can now just say this is y being equal to x squared plus 3x plus 2. So this is basically how you sketch the graph of a quadratic equation. And then let's move on to the next question, where I'm going to show you the next method. So the next question is this one. I don't know if I should solve this one, or that one. Okay, let me solve this one. So this one, we first use the completing the square method. So we're saying y is equal to, we factor out the -1 there, so we're going to have x squared to remain alone there, and then we have -6x there, and then we have plus 7. So we find half of 6x there, so we're going to have -1 outside, and then half of 6 is 3, so we have negative, we say plus, then -3 squared minus -3 squared. Then we say minus 6x, then we close the brackets, then say plus 7. So here we have y, so y is equal to, and then we write our -1 like that, then we complete the square of this part. We're going to have x minus 3 in brackets, then we square it, and we say minus 9, and then this is what we're going to have, and then our y will just be equal to negative x minus 3. When we open the brackets there, we distribute the negative, so -1 times -9, we get positive 9, then we say plus 7. So our y is just going to be equal to negative x minus 3, then this will be equal to 16. So now, to get the turning point from this expression, the value of x at the turning point, you get it by equating x minus 3 to 0. So when you equate this to 0, you get x being equal to positive 3, and then the value of y at the turning point, you just get this part, so y is just going to be 16. So our turning point in this case is just going to be 3, 16. Now to get the values of x, at the turning point, you simply just put 0 this side, because we know to say in the x-axis the value of y is equal to 0. So where there is y here, we're going to put 0. So we're going to say negative x minus 3 squared is equal to, you take, okay, let me just follow the steps. I wanted to do a shortcut. So plus 16 is equal to 0. So we take this negative 16 and then divide by -1 on both sides. We're going to have something like this. Then when you take the square root of both sides, we're going to have x minus 3 being equal to plus or minus 4. So this is just going to give us x being equal to positive 3, and then plus or minus 4. So our first value of x will just be equal to 3 plus 4, which is 7. Then our other value of x will just be equal to 3 minus 4, which is -1. And then from there, what we now have to find is the y-intercept. So the y-intercept in most cases, you just get this. 7 there. The constant, just get the value of c there, or rather you just replace where there's 0, where there's x with 0, since we know to say in the y-axis the value of x is 0. And then so this is the x these are the x-intercepts we have. Then the y-intercept we have is supposed to be the y-intercept that we have is supposed to be it's just going to be equal to 7. And then this part here, this value of x here, this, sorry, let me say not this one, but this one, this other one. So this one, despite it being called the value of x at a turning point, it's also called this one is also called the line of symmetry. So in case you hear a lecturer or an examiner asking you to find the line of symmetry, this is the one. And then if they ask you to find the maximum or the minimum value, you just get 16. This is the minimum or the maximum value. And then according to this equation, the value of a there, when you look at a from this equation, a is less than 0 because it's -1 there. So when it's less than 0, we expect to have a maximum value. So meaning this 16 is called the maximum. So our graph is supposed to come out like this. So now let's quickly move on. Let's quickly sketch. So if we're sketching now, we're going to have our graph to look like that. Have 0 there, and then we first put our x-intercepts. We have -1, then we also have 7. Then our turning point is 3,16. So I'm going to say 3. I'll write my 3 to be there, then 16 can even be there. So our turning point is somewhere there. So we can sketch like that. So this is our turning point. This is our turning point. And then what else? I think this is all for sketching. Then the line of symmetry is just x being equal to 3. So you can even show it if you want. Which is just a line which is dividing the curve into 2 equal parts. So these are basically the two methods that I use to sketch the graphs of quadratic equations. So let's quickly move on to part B of question 2. So part B of question 2 is saying, for what values of k will the function, this function f of x being equal to x squared plus 6x plus k, cut the x-axis twice, touch the x-axis, and have no x-intercepts? So sorry, don't look at this. So it's just an error. So for the first part here, when it cuts the x-axis, meaning it has real roots. So what happens when an equation have real roots? It means that the discriminant g is greater than 0. So meaning they are asking us to say, for what values of k will the function, this one, the function f of x plus k, f of x is equal to that, then plus k, cuts the x-axis twice. So in other words, what they are trying to ask us is that when is the discriminant going to be greater than 0? So it is only going to be greater than 0 when b squared minus 4ac is also greater than 0, when it has real roots. So we know to say when it cuts the x-axis twice, then it has real roots. And then so while there is b squared there, you say 6 squared, which is 36. So let me just write it, 6 squared minus 4, and then our a from this equation is 1, and then our c is simply just k, and then this one was saying supposed to be greater than 0. So we have 36, we take it to the other side of the equal sign, meaning we have -4k this side, being greater than 36. 6 squared is 36, so this one is going to be negative 36 when it goes to the other side of the equal sign. So when we divide everything by negative 4, so when divide by negative, this sign changes. We're going to have k being less than so 4 into 36 is supposed to be 9. Yes, so k, when for all the values of k which are less than 9, we can get this function to have real roots. So let's quickly try now to check let's try to move on to the next question, the second part here. So when they say it touches the x-axis, meaning it has equal roots. So when it touches the x-axis, it looks like this, meaning it only touches the x-axis at one point, meaning it has equal roots. So when it has equal roots, meaning the discriminant is equal to 0. So this one only occurs when it has equal roots. Okay, I don't know how to write letters using this. Okay, so when it has equal roots, so when it has equal roots, so when d is equal to 0, it has equal roots. So we're going to have b squared minus 4ac being equal to 0. So b squared is going to be 6 squared minus 4 times 1 times k being equal to 0. So when you simplify this, we're going to have 36 minus 4k being equal to 0. So 36, when it goes to the other side of the equal sign, you're going to remain with 4k this side being equal to 36, or negative 36. So when you divide by negative 4, our value of k will now just be equal to 9. So let's quickly move on to the other side of to this other part. So when they ask you to say for what values of x, or sorry, for what values of k will this function have no x-intercepts? If it has no x-intercepts, meaning it's either like that, or like that, or like that. It's not cutting the x-axis at any point. Alright, so if this is the case, what you do is you simply do what? You simply say this discriminant, when it has no real roots, or it has when it has no real roots, sometimes they call these types of roots as it has complex roots. When it has complex roots, or no real roots, or imaginary roots. So when it has complex roots, it's just the opposite of real roots, meaning d is supposed to be less than 0. So when d is less than 0, we're going to say b squared minus 4ac should be less than 0. So from there, b squared, what is our b squared? B squared is 6 squared minus 4ac is less than 0. So from there, we now say so our a is supposed to be 1, and then our c is k. So when we simplify this, we are just going to be, this is 1, hope you are seeing it. Okay, let me just write it properly. So this is going to be negative 4k being less than, when this 36 goes to the other side of the equal sign, you get negative 36. So divide by -4, divide by -4, you get your value of k to be equal to, oh sorry, not being equal to, but this is going to be greater than 9. So you only have no solutions for this quadratic equation when you have the value of the value of k being greater than 9. Alright, let's quickly move on to the last question, which is C, part C of question 2. So part C says, for the quadratic equation 7 plus 4x minus 2x squared, find the equation of the axis of symmetry, coordinates of the vertex, the x and y intercepts. Hence, sketch the graph of the function. So I'm sure this question is not a problem, because I explained what the axis of symmetry is, the x and the y intercepts and everything. So I don't know which method you can use, but for me I'll just use the simplest method, where I'll say finding the x. Okay, anyway, let us just use the normal method, which is completing the square method. So we're going to complete the square of this equation here. So first let us rearrange it. So when we rearrange it, we're going to have -2x squared, then plus 4x, then we have plus 7. So we factor out the -2 there. So when we factor out -2, we're going to have x squared there, and then we have -2x, then we have plus 7 there. So we complete the square of what is in the brackets there. So we're going to have x squared plus -1. So half of this is -1 squared, then minus -1 squared, then minus 2x, then we say plus 7. So this is just going to be equal to -2, and then in brackets there we have x minus 1 squared, then minus 1 in brackets plus 7. So this will give us, when you open the brackets by multiplying with -2 there, we are going to have something like this. This is x minus 1, then plus 2 plus 7. So here we have -2, then have x minus 1 squared plus 9. So this is f of x. This is f of x. And then, so what we have here is f of x. To find the line of symmetry, you just get what is in between here and equate it to 0. So when you equate this to 0, you are going to have x being equal to 1. So this, we have answered the first part, the equation of the axis of symmetry. So we've answered the first part. So this is the first part. Move on to the next part, which is coordinates of the vertex, meaning the turning point. The coordinates of the vertex is just the turning point. So to find the turning point, you just get this value of x there. So the vertex v, so the value of x at the vertex is 1, comma, and then the value of y at the vertex, you just get this 9 there, 1, 9. We've answered the second part. These things are simple and straightforward. So the x and the y intercepts. So the y intercepts, we know to say it's just going to be 7. You just get that part as your y intercept. And then to find, so in short, the y intercept, we found the y-intercept, which is just 7. You just get the constant, and then to find the x-intercepts, now you just equate this equation, this whole equation to 0. So we equate negative 2 x minus 1 squared plus 9 to 0. You equate this to 0. So when you equate this to 0, you take this 9 to the other side of the equal sign, meaning you're going to have this means that you're going to have negative 9 on the other side. Then when you divide by 2, you have something like this, x minus 1 squared being equal to 9 over 2. When you find the square root of both sides, there you get x minus 1 this side, and then this other side you have 3 over the root of 2. Of course, this is supposed to be plus or minus. So when you take negative 1 to the other side of the equal sign, you have your value of x. You're going to have your value of x. The value of x to be equal to 1 plus or minus 3 over the root of 2. So now, if you having found this, you can now go straight into sketching. So we can now start sketching. So we can now sketch. Our turning point is 1,9. So I can say this is 1,9. So this is our turning point. Then when you look at the value of a here, it's greater, it's less than 0, hence it's going to be a maximum. So it's going to be like that. So at this point where it's meeting the y-axis, this is the 7, which is the y-intercept, and then where it's meeting the x-axis, that's where we have our 1 plus or minus 3 over the root of 2. Wait, first let me just put, so this is the vertex V, and then this is the axis of symmetry. Can also show it and say this is x is equal to 1. Then what else have we forgotten to put? Just put now there these 2 points. So this one, the small one, will be this side, which is 1 minus 3 over root 2. Then the bigger one will be this side, 1 plus 3 over the root of 2. So we have sketched the graph. This is how simple these things are. Let's quickly move on to the this was the last question. This was question 2C. So thank you very much for watching today's tutorial. Make sure that you don't forget to subscribe to my channel, and don't forget there's a Telegram group where I post all these tutorial videos, and you don't want to miss this. So inbox me on my upline, which is just 0960108064, and then I'll add you to the group. Yeah, so subscribe, click on the button which says subscribe. See you in the next tutorial video. Shalom.